Hello everyone, welcome to the SR Maths Learning. So in today's our lecture number 5. So in this video, we are going to discuss the total probability, which is useful to learn the Bayes' theorem and which is very important in the probability. So let's just see what is the total probability. If A1, A2, A3, so on, AN are mutually exclusive and exhaustive events of random experiment associated with the sample space S, such that P of AI is greater than 0 for I is equal to 1, 2, 3, n. And A is any event which takes place in conjunction with AI, then P of AI is equal to summation of I is equal to 1 to n. P of A by AI is called a total probability. This is the total probability formula. So what he told in this statement, let's see once. A1, A2, A3, so on, AN are mutually exclusive, it seems. Mutually exclusive events. Mutually exclusive events. And exhaustive also. That means a simple example I will tell here. If A and B are mutually exclusive events, then A intersection B is a null set. That means P of A intersection B is equal to 0. Then there will be no elements. So no problem. So you'll see here, the sample space I written here in the diagram, I drawn. So in a sample space, I took n number of mutually exclusive and exhaustive events. Among that, A is one of the event. Okay. So how can you find that P of A, probability of the event A? That is the total probability that we are given here. Summation of I is equal to 1 to n, P of AI into P of A by AI is the total probability. So let's see. Here I clearly given that A1, A2, A3, so on, AN are mutually exclusive events and exhaustive events also. That means A1 intersection A2 will be a null set. A2 intersection A3 is a null set. Like this, whatever you will take, some AI intersection AJ will be a null set. If I not equal to J. This is very important for I comma J is less than or equal to n and greater than or equal to 1. And here A1 union, A2 union, A3, so on, union n. If you add all the elements of these events, we should get a sample space because they told exhaustive events. Exhaustive events meaning is the sum of all the events, probability of sum of all the events should be equal to sample space. So since we have AI intersection AJ is the null set, even we include this A here, A intersection AI intersection AJ also will be a null set. It means not equal to 0. So it's not equal to 0. So A intersection, that is A intersection AI and A intersection AJ are mutually exclusive disjoint. Are mutually exclusive means disjoint for I not equal to J. Okay. So now what I will do is I want P of A, probability of the event A. How can I write this one is P of A intersection S, because A intersection S is nothing but A only. But yes, what I told here, that A1 union A2, right? A1 union A2 union so on union AN. I written like this, yes. So I can take this one as P of A intersection A1 union A intersection A2 union so on A intersection E. I can write like this, right? So which can be classes, these are independent. P of A intersection AI plus P of A intersection A2. So A intersection A2 plus so on plus P of A intersection AN we can write. So from the condition of probability, P of A intersection A1, we can write like P of A1 into P of A by A1 plus P of A2 into P of A by A2 plus so on plus P of AN into P of A by AN. So this we can write summation of I is equal to 1 to N P of AI into P of A by AI. So this is what we can write. So this is nothing but the total probability theorem. So this is the way how we will prove this. Okay. Let's just see Bayes' theorem based on the total probability. So even Bayes' theorem also statement almost the same, like A1, A2, AN are N mutually exclusive and exhaustive events of a random experiment associated with sample space S, such that P of A is not equal to 0, and A is any event which takes place in conjunction with any one of A. Then P of AK by A means A already happened. So what is the probability of happening AK among this A1 to AN? Is P of AK into P of A by AK divided by P of A means total probability. So let's see. See already how can we find this one is, see clearly P of A, we know from the total probability that summation of I is equal to 1 to N P of AI into P of A by AI, right? Here in the Bayes' theorem, what Bayes' theorem says, if we know that A is happened among this A1 and A1 to AN, what is the probability that that event A comes from AK? I mean, this here. AK, the event comes from A. That we can write like P of AK into P of A by AK divided by P of A, right? According to the, and this, see this, how it will come? P of AK intersection A by P of A. AK intersection A means P of AK into P of A by AK by P of A. So here P of A already we know. So that's why P of AK into P of A by AK by summation of I is equal to 1 to N P of AK into P of A by, I mean here this is K, P of A by AK. This is the Bayes' theorem, right? So from the conditional probability itself we will get this. So this is our Bayes' theorem, AK by A. So let's see problems on Bayes' theorem. Here is one problem. The problem is 3 boxes numbered 1, 2, 3 contain the balls as follows. So in first box, white balls 1, black balls 2, red balls 2. In second box, 2, 1, 1. In third box, 4, 5, 3. So one box is randomly selected and a ball is drawn from it. If the ball is red, the drawn ball is red, then find the probability that it is from box 2. It is from box 2. So let's see. So what they're given here clearly, 3 boxes are there it seems. First, let's select one box from the 3 boxes. That can be done. Selecting a probability of selecting box 1 is 1 by 3 because 3 boxes are there. Out of 3 boxes, 1 box can be selected in 1 by 3 ways. And box 2 also we can select in 1 by 3 ways. Even box 3 also we can select 1 by 3. So here the selection of boxes are not depend on any other boxes. So these are purely mutually exclusive events, and if you'll add this all, so you'll get the total probability, that is the sample space 1, means exhaustive events. Since these are mutual and exclusive and exhaustive events, we can apply the Bayes theorem here. So first of all, hope you understand this. The selection of box is equiprobable. Equiprobable in the sense all are having the same probability. So let us denote R. R be the event. R be the event of getting red ball. Right? So let's think we are selected the black box 1, and from that, what is the probability of selecting the red ball? Total number of balls we have 6 balls here. Sorry, this is 3 balls, right? 6 balls total we have. Out of that 6, 3 balls we can select from 3 balls, red balls, 1 red ball we can be selected in 3 7. That is 3 by 6, means 1 by 2 ways. Come to the box 2. Probability of getting the red ball from the box 2 is, there in the box 2, total 4 balls are there. Out of that, only 1 red ball. So next, probability of getting red ball from the box 3 is, total 12 balls we have, out of that 3 balls are red. So 1 by 4 is the probability of getting a red ball from box 3. Now what they're asking is, find the probability that the red ball is from box 2. So the red ball is, so we already know that it is a red ball. We have to find out that came from the box 2. So that means, according to the Bayes theorem, P of B2 into P of R by B2 divided by P of B1 into P of R by B1 plus P of B2 into P of R by B2 plus P of B3 into P of R by B3. So this is the Bayes theorem. So according to Bayes theorem, we can solve this probability of getting red ball from box 2. So P of B2 we got 1 by 3. So into 1 by 4 by 1 by 3 into 1 by 2 plus 1 by 3 into 1 by 4 plus 1 by 3 into 1 by 4. So this is 1 by 3 into 1 by 4 by 1 by 3 is common. So here it will be 1 by 2 plus 1 by 4 plus 1 by 2. So 1 by 3 cancel. 1 by 4 by 1, which is 1 by 4. So here we can conclude that probability of knowing the red ball came from the box 2. That's 1 by 4. So hope you understand this clearly. Let's see the next question. So here the example 2. A bag contains 5 balls. 2 balls are drawn and found them to be red. Find the probability that all the balls are red. So let's see. First, what they're given it. From the given information, 2 balls are drawn and found them to be red. Means very clearly we got it to know that there are at least 2 red balls. So it is very clear that there are at least 2 red balls in bag. 2 red balls in bag. That is to confirm. So let us assume RK be the event that the bag contains K red balls. Here K value is minimum to minimum, we are getting to know that 2 balls are there. So 2, maybe 3, maybe 4, maybe 5. So here R2 means 2 red balls in the bag, or 3 red balls, or 4 red balls, or 5 red balls. These are mutually exclusive and exhaustive, because drawing the balls never depends on the drawing the other balls. Okay, so these are all equiprobable. All are equiprobable. Equiprobable means drawing the number of balls, means drawing the 2 red balls is drawing the 3 red balls, or drawing 4 red balls, or drawing 5 red balls, or 1 by 4, or 1 by 4. Okay, so let A be the event that the 2 balls which are drawn are red. Let A be the event. Let A be the event that the two balls which are drawn are red, which are drawn are red. So we know that already we drawn the 2 red balls. So we have to find all the balls are red, means R5. That means P of R5 into P of A by R5 divided by summation of K is equal to 2 to 5 P of RK into P of A by RK. Here we can find P of R2, but already we know 2 red balls. So out of 2, that 2 we will select, and out of 5, 2 ball selection. That is 1 by 10. P of A by R3. So selecting 2 balls out of 5 balls, and if you know 3 balls are there from the 2 red ball selection. This is 3 by 10. So next, probability of selecting 2 balls from the 4 red balls is 4C2 by 5C2, which is 6 by 10. Probability of selecting the 2 balls, when you know that there are 5 red balls, 5C2 by 5C2, which is in one way. So let's substitute here. P of R5 is 1 by 4 into P of A by R5 is 1 divided by 1 by 4 into 1 by 10. That is, if you are knowing, we are drawing the 2 red balls, if we know that there are 2 red balls, plus 1 by 4 into 3 by 10, if you know the 3 red balls are there in the bag, 1 by 4 into 6 by 10, when we know 4 red balls are there, 1 by 4 into 1, when we know 5 red balls are there in the bag. So 1 by 4 into 1 by 4 is common, 1 by 10 plus 3 by 10 plus 6 by 10 plus 1. So these two gets cancelled. So this we can write like 1 by 1 plus 3 plus 6 plus 10 into 10, which is 10 by 20. That is nothing but a probability of all the balls are red. If you are knowing that 2 balls drawn, 2 balls are red, is 1 by 2. So hope you understand clearly. So let's see one more problem here. A card is drawn from a card from pack of 52 cards is lost. A card from pack of 52 cards is lost. From the remaining cards of pack, 2 cards are drawn and are formed to be spades. I think it's found. It's found to be spades. Find the probability of the missing card is to be spade. Okay, missing card is to be spared. So let's think if the missing card is spared, remaining cards 52 minus 1, so means 51 cards only left out because we lost the one card, that is spared. Means in this remaining spades are 12, clubs are 13, hearts are 13, diamonds are 13. So now let us assume EC, ES, EH, ED are the events of losing a card, from clubs, spades, hearts, and the diamonds respectively. So these are mutually exclusive and exhaustive events. Let us think A be the event of drawing two spades cards. Where two cards are drawn. Okay. So let us think two spade cards are drawn. So then P of A, that is from spades, is there are 12 spades only available. So from the 12, 2 we can take out of 51, we can take 2. This is enough. So this is from the spades. If I'll take the two cards, here A is drawing the two cards. Event of drawing two cards. Okay. So two cards from the clubs. 13C2 by 51C2. Similarly, drawing two cards from the hearts is 13C2 by 51C2. And similarly, drawing two cards from the diamonds, 13C2 by 51C2. So here, probability of selecting the suits means there are 4 suits, that is spades, clubs, hearts, and the diamonds. So there are total 4 suits. So each and equiprobably it will be selected. So it is 1 by 4. Now what I should find out here? Probability of drawing two cards from the spades. Okay. So that is P of ES into P of A by ES, summation of, here summation can't work because all are different. We cannot number it. P of ES into P of A by ES plus P of ED into P of A by ED plus P of EC into P of A by EC plus P of E hearts, P of A by E hearts. This is the way how we will write the Bayes theorem. So this is nothing but simply all are equal, these and these and these all are equal to 1 by 4. This is also 1 by, it will be cancelled. P of A by ES by P of A by ES plus P of A by ED plus P of A by EC plus P of A by EH. This is 12C2 by 12C2 plus 13C2 plus 13C2 plus 13C2, which is 12 into 11 by 12 into 11 plus 3 into 13 into 12. So which can be simplified as 12 into 11 by 12 is common. 11 plus 39. It's 12 and 12 cancel. 11 by 50. So probability of the drawn two cards from the spades is 11 by 50. Hope you understand these examples clearly. Please revise the problems immediately from your textbooks, whatever available, to understand it more and more clearly. Thanks for watching my videos. Please do subscribe to watch more videos. Thanks for your support.